All right, hello everybody. So what we're going to do is we're going to cap off the first unit with a really quick discussion about software teams and the organization of software teams, specifically talking about how communication between team members and between teams inside of a software organization can really make or break a project or a product, and how these things are very, very, very important, even though they're something that maybe seems kind of trivial at the face value. So we have talked at enormous length about how software is complicated and software is really big. And the obvious fallout of that is it's really, really hard, if not impossible, for one person to generate a piece of production code that does anything kind of meaningful. So if you think about coding your own word processor or spreadsheet engine or database engine or banking application, these kinds of things typically require a lot of teamwork in order to actually get correct. Teamwork becomes a kind of central aspect of software development. So as a software engineer, not only do you have to be really good at coding, not only do you have to be really good at eliciting or soliciting requirements from a client, you also have to be able to work in a team with other software engineers that very likely have their own takes on the problems that the clients have and how best to solve those problems. And this is such a big deal that if you look at the syllabus for the course, teamwork is one of the ABET requirements or ABET checkboxes that this course satisfies for the degree program. So teamwork is really, really integral to the process, but also B, extremely non-trivial, even though at face value it kind of seems to be. So the fundamental issue around trying to develop software inside of a team is that as the size of the project necessitates additional team members, you have to coordinate communication across an increasingly large team. So if you understand that a requirement is likely to change in the next couple of days, but your teammates do not know that, then they could potentially waste time trying to fix something or implement a piece of code that is going to ultimately be thrown away and replaced with something else. So this is kind of just a trivial example of what I mean here. You could have coordination efforts for all sorts of different reasons. But as the size of your team goes from one person to 2 people to 4 people to 8 people, it becomes increasingly difficult for those 8 or 12 or 15 people to understand what all the other people are working on and what all of the other people know about the project behind the scenes. It also becomes less clear how to distribute work. So in the spring, I had one software group in this course that was actually 6 or 7 people big, and one of the pieces of feedback that group gave toward the end of the semester and kind of a debrief is that the size of their team made it very difficult to keep everyone busy. One of the things that we'll talk about at the beginning of next week is how you're graded based on the code that you can contribute to the project in addition to all of the other things. And if you have team members that are kind of idle, just sort of sitting around, that's not necessarily great for your group project in the course, but it's also not very great as a software organization. You don't necessarily want people just sort of sitting around doing nothing, waiting on work. And so distributing available work becomes extremely important and harder to do as the size of the team expands. And you also have this issue where if you're trying to do something like continuous integration, where 9 or 10 or 12 people are trying to check into the same branch of code and ensure that the branch actually builds and you can run the application after every check-in, the more people that are checking in changes, the harder that becomes to do. And so you have to spend some time communicating between developers about potential breaking changes, or when you break something, you kind of have to tell everybody else how to fix it, or potentially you're going to derail the entire organization until you can fix your own problem. So within a software organization, the size of something like Microsoft or Amazon, or you pick your favorite large software organization, there are various ways to structure individual teams. And so by software teams, what I mean here is really maybe Scrum teams or teams that are tasked with building one specific piece of a larger product or project. And so you might see a development or a distribution of labor based on maintenance engineers versus development engineers. And so what this means is that maintenance engineers really come after the fact and fix bugs, or they attempt to implement feature requests that are after release. So a client comes to you and says that they want some new feature. A maintenance engineer might be tasked with building that new feature, but development tasks prior to release would be built or staffed using the development team instead. You could also have research and maintenance and development. And so the research engineers would be engineers that are working on kind of bleeding edge or cutting edge features. They're using bleeding edge technology that may or may not be stable enough to actually integrate into your production code. So just like development is to maintenance, they're working on maybe the very next iteration, not necessarily maintenance for the existing release. Research is even further in the future. So that's a group of people who are looking at cutting edge things to add to the system or to the project, and potentially not all of those features or all that technology is actually even going to make it into the product at all. You can also go along functional lines. So if you have something like Microsoft Office, you might have teams for Word or for Excel or for Access, pick your favorite application, but you also might have a centralized framework team that kind of handles all of the Windows components, all of the ribbon features, plumbing that allows the applications to talk to each other, so exporting or copy and pasting from Word into Excel or vice versa. So you can have teams that are split up based on sort of the functions that they provide to the overall project, or also functional lines in terms of their own knowledge base. So you could have people who are more interested in for example, SQL, or they're more interested in UI development, or they're more interested in back-end or front-end development. And so you can divide the labor by any of these kind of different buckets of work. You could also look at dividing a team up by the layers of a multi-tiered application, like I said. So you could have people who are working on the UI, people working on business logic on the client side, business logic on the server side, and then kind of the persistence layer where you actually save things into a database somewhere or onto a file system. And so the nature of what you're trying to do. So if you're trying to build the next great office suite, or if you're trying to build a hospital records management system, that end goal should be what drives how you split up your teams. And in addition to that, the resources that you have available should also drive that decision. So if you have people that are clearly better at SQL than they are at UI development, you definitely want to utilize those resources wisely. So you want to make sure that those people are fully leveraged in the area that they are the most skilled in, if at all possible. So let's say, again, that it takes one person N years to build a complete system from scratch. And so if you think about a couple of lectures ago, we talked about how if you were the most rockstar developer ever, it might take you up to maybe 3 years to build a rudimentary kind of energy management system for an electronic car. It might seem intuitive that if you added M team members to the team, you would effectively divide those N years by a factor of M. Basically, everybody would take their fair share of work, and then you would be dividing that overall N years of work by the M people that you've added to the project. Unfortunately, this does not work out. And so there's a kind of famous paper called the Mythical Man Month that goes through this, and I'll post a link to that article or actually I'll try to grab the full text of the article and put it in Canvas. But suffice it to say, basically what happens is you can add as many people to a team as you want, but unless you scale the communication between the existing people on the team and the new people on the team, what will actually happen is this sort of comedy of errors. You will have a whole bunch of people checking in code that breaks other people's code. You will have people walking all over each other during meetings. You will have people second guessing architectural decisions that ultimately drive even more changes into already volatile requirements. Everything just kind of becomes a sitcom, and you don't necessarily need that, especially if you're trying to add resources to the team in order to speed up development. Often what actually happens is development will slow down as the team kind of absorbs these new resources and gets them up to speed. Now, once your team actually does that organization, it absorbs those resources, everybody gets on the same page, everybody's kind of at the same, if not skill level, but familiarity level with whatever project you're working on, then obviously the throughput of the team will increase because you'll have more people that can actually physically type on keyboards. The important thing to note, though, is that the amount of ramp-up time after you add a person to a team could be non-trivial. It could take weeks or months for that person to actually understand what is going on to the point that they could be as effective as an original member of the team. So basically what ends up happening is you have to figure out how to take and integrate new people into a team wisely if you choose to basically bulk up a team in order to power through an issue. And so the hardest part of that is making sure that new members of the team have the same institutional knowledge as the people who are already on the team. And unless you can democratize that knowledge, it is going to be very, very difficult for you to ensure the quality of the system because you basically have rogue agents just sort of doing stuff in the system, and you can't necessarily go around behind them and double check everything that happens because if you could do that, you wouldn't be in the situation where you need to add resources to begin with. So to that end, communication is absolutely everything inside of a software organization. So if you do not have good communication, it is very, very likely that you're producing subpar software, and it's very, very likely that the organization itself will ultimately fail, if not outright, but it will fail in sort of minor ways and not be as successful as it could otherwise be. So there are tons of sort of user-friendly, non-intrusive ways to foster communication. Most of those are technological in nature. They are often asynchronous. So we're talking about things like Discord, we're talking about things like Slack, even things like email that allow you to ask questions and not necessarily get an immediate answer, but get a well thought out answer when a person has sufficient time in order to actually read and understand what you're asking them. So there is a widely held belief and kind of saying that meetings are what very frequently kill companies. And as a sort of anecdotal tale, I was once in a consultancy that was working on a very, very, very large sort of ERP project for a very large accounting company. And it got to the point that the project managers for the accounting company would actually have meetings to plan other meetings. And so once you get this sort of inception level meetings about meetings about meetings about meetings kind of situation, you start realizing the kind of return on investment that you get from having the final meeting goes down exponentially. There's some diminishing returns there. And so What ultimately happens is if you try to maximize communication by maximizing the number of meetings that you have per week or maximizing face-to-face touch points, you ultimately strangle everyone's ability to actually work because instead of writing code or fixing bugs or testing software, they are sitting in a meeting talking about doing all of those things. This is called in a lot of places organizational paralysis. You basically have tons of meetings. Everything is extremely well planned out, but none of those plans come to fruition because nobody's actually ever doing anything. They're only just talking about and communicating about the things that need to be done. This is very easy to have happen, and it kind of mimics the process that you may have already experienced in your undergraduate career, right? Where you sit around with your friends and you talk about how much homework you have or how anxious you are about a bunch of tests instead of studying for the tests. And then your anxiety sort of becomes a self-fulfilling prophecy that you now have insufficient time to prepare for things that were causing you anxiety that required you to talk about the anxiety, and it becomes this giant loop. You definitely do not want to be in that situation as a software organization. So this is why asynchronous communication is extremely important because it does not require a person to stop their train of thought or stop what they're doing in order to actually become engaged in the conversation. So tools like Slack, tools like email are extremely important because they allow a person to have blocks of time to themselves to actually get things done, and then they can also sort of engage in communication in blocks where they otherwise would be doing other things that are maybe less efficient. So if you think about what, quote, true Scrum is sort of daily stand-up meeting style situation. And the idea behind all of those daily Scrum meetings is that they should be as short as physically possible, and they should have as much information in as short of time as possible. And so if you think about using asynchronous communication as an extension of Scrum meetings, you want to do exactly the same thing. So you don't necessarily want to write your team leader a 5-page email about a specific question that you have. You want to kind of keep it short and sweet so that they can very quickly process the information that you need and then provide you a meaningful reply. One of the sort of tales as old as time situation is that documentation serves as communication inside of almost every software organization on Earth. And it's also true that almost every software organization on Earth is very, very bad at documentation. So if you think even of somebody, an organization the size of Microsoft, they have extremely good documentation on MSDN. You can find documentation on every bell and whistle and button and slider in Azure. However, what ultimately happens is because they have so much documentation, anytime anything changes, that documentation is never updated. So basically what happens is you have this catch-22 situation. Either you have too much documentation and it becomes impossible for you to update them to be as flexible as your agile development process is, or you have insufficient documentation, and because of your lack of documentation, people have no idea what is actually going on. So it takes them a very long time to understand the code that you've written because it doesn't have any comments. It takes a very long time for them to understand how all of the modules inside of the system fit together because there are no diagrams, there are no explanations of how anything actually hangs together. So you can see that even a very kind of trivial decision about whether or not you should have documentation can easily turn into this sort of risk-benefit analysis that's extremely gray. At what point is a lot of documentation too much documentation? So you run into situations where you're spending a lot of time, A, making documentation, and then B, updating documentation in order to be as agile as you need to be. Or you have too little documentation, and then things start going very, very wrong, and now you're wasting even even more money because you were trying to pull people out of the weeds, or you're trying to re-educate people or remediate bugs that have been introduced because of this lack of understanding, because of the lack of documentation. To cap off that idea, most of the people that are making these risk-benefit analyses, most of the people who are ultimately deciding what level of documentation is the appropriate level of documentation, they're software engineers. They're people exactly like you. They have computer science backgrounds, they have IT backgrounds, they do not necessarily have business backgrounds or project management backgrounds, and typically they're extremely uncomfortable trying to make these decisions at first. And so this is a thing that will absolutely happen to you fairly early in your career. You'll be given some sort of project to lead, and then you'll be expected to make a lot of the decisions that you were never actually really prepared to make. And so this is a thing to just sort of be aware of. You have to take the data that you have available and make the best decision that you can, and kind of be as flexible as possible, and kind of go roll with the punches, so to speak. So the last thing that I want to talk about is the fact that not all software teams are made entirely out of engineers, or entirely out of specifically software engineers. There are QA or QC teams, which stands for quality assurance or quality control teams. These teams or team members exist purely to minimize software faults. They want to maximize client satisfaction by making sure that the code that you're generating and sending out to market actually reflects what the client wanted, or the end user experience that the organization had in mind when they actually designed the piece of software. You also have CRT teams. These are fairly new. The acronym stands for different things at different places, but it could be a crisis response team or a client response team. And basically what these teams are is they're senior developers. They are engineers that are familiar with a wide array of the subcomponents of the system, and their job is to mitigate any in-progress failures that are particularly problematic. And so by particularly problematic, I mean they're happening in a production system. So an example would be we went to version 2 of the system, and now suddenly all of our users can't log in. That's a huge problem, and so a CRT team would actually be on site or in the wind somewhere trying to fix that issue for the specific client, and kind of make them as happy as possible, and sort of remediate the issue. You also have project management teams or project management team members that manage all of the projects. They do things like fill the sprint with tasks. They prioritize tasks. They staff tasks. They figure out who is the best engineer for what specific task. And they kind of set client expectations based on all of those staffing decisions. And so it's really, really important that PM members or project management members of the team have the technical prowess to actually have meaningful technological conversations with engineers. And it's extremely important that engineers have at least a minimal understanding of project management, so that they can also contribute to planning sprints and prioritizing work and setting client expectations to be reasonable things. And so at the base of everything, it's true that communication between various teams is as important as communication between members of a single team. So if you have a whole team of quality control engineers, and they never tell the engineering team about the worst bug, because the worst bug is maybe the worst bug for the organization and not for the client, then obviously you're going to ultimately have a huge problem. So communication between Scrum teams, communications between all of these various levels of the organization are extremely important, because they provide context for everybody to do their job more efficiently. The biggest problem around trying to interface between all of these different teams is the fact that somebody can fundamentally break everyone else in the organization if you aren't really, really careful. And so software interfaces are basically the points where all of the different individual pieces of a software system meet each other. And so these are often referred to as handshakes. And basically, it's the point where two modules meet each other. And so this could be your database layer connecting to the server-side business logic. This could be your application connecting to the Yelp API, so on and so forth. And these things represent the highest risk of failure because if you change, for example, a method signature that is used in another module, you could obviously make that module completely fail. And so that is a massive point of communication. If you fail to tell your team that you have modified a public interface or modified a public method signature, you could bring the entire system down and nobody would actually be aware of why it's down. And they would have to spend a significant amount of time potentially trying to figure out why everything is suddenly broken. So communication is a thing that has to happen from top to bottom throughout the entire life cycle of the development process. These are all examples of when communication is really important. And the big kind of obscure thing is that communication from the client back to the software organization or the software development team can actually happen even through something like raising bugs. So the client can say, hey, I expected this button to create a new time entry, and when I clicked it, the whole application crashed. That is a form of communication from the client indicating that the software organization has to do something, has to take some sort of action. And so bug tracking systems are something that we're going to cover in a fair amount of detail in the course. It's unfortunately kind of toward the end, so I think I'm going to post some recitation videos about Git and about Jira and some of the other sort of management or ALM tools that you could use. But basically, bug tracking systems are really the best way that a client can tell you that something is going wrong and can indicate to you how wrong it's actually going. And so the idea here is you have two options. You can have an open bug report system where a client can come in and tell you anything that happened wrong, or you can have a system where the client calls a support organization and the support organization is responsible for actually raising the bug to development. In this latter case, you're often able to get better bug reports because the people who are entering the bug reports actually have some information or some idea of what the system is actually supposed to be doing. So it's very important to kind of try to curate bug report information, however you do it. But it's important to note that bug reports are often not thought of as a form of communication, but they're actually a very, very important form of communication that usually spans the organizational boundaries. So often it's communication from an outside entity or an outside client back to the software organization that is very helpful information if you want to continue to get paid and operate. So these bug reports can also serve as communication tools between layers in the organization. So if you have an application in an application suite, so Word, for example, inside of Office, and it had 4 bugs, and now suddenly you have 400 bugs, that indicates that something somewhere fundamentally broke. Something in the process of development broke, something in the framework underlying the entire application broke, something in testing certainly broke because you shouldn't have released that piece of software into the wild. Likewise, if you had an application that had 400 bugs and now it has 4 bugs, somebody clearly needs a raise. Somebody has done something to that application's development process that has made it much more robust, that has made it much more resistant to failure, and that needs to be rewarded, but it also probably needs to be carried over to other applications in the organization that might be struggling. So bug reports are not only helpful from the client back to the organization, but they're also an important metric for the organization to try to help it get better over time. So I'm going to do a whole video about the class project because it's going to be slightly complicated because of the remote nature of the course. But one thing to keep in mind is that throughout the class project, you're going to come face to face with a lot of the issues that we've talked about this first week. You're going to have to generate a lot of requirements documentation very quickly. You're going to have to generate a lot of code very quickly. You're going to have to learn people's quirks. You're going to have to meet people. You're going to have to understand how to work in a team very quickly. And all of these things are extremely difficult to do, and I understand that. This is just like a sort of partial list of things that might happen to you that might go wrong, and I guarantee you that you're probably not going to stumble upon something that did not already happen in the spring. So this slide really serves at two purposes. One, just be wary that the class project is not going to be easy to do. And two, be aware that I am aware that it's not going to be easy to do, and I'm kind of here to help you however that needs to happen. So I'm happy to meet with your team individually to talk through technological issues. I'm happy to talk through specific diagram techniques. I'm here specifically to help you with the course material, but even more specifically to help you be successful in the class project. So I'll post a video about how to get started on the class project at the beginning of the next module, but just be aware that the content of the course is going to seem a little trivial. It's going to seem like something that is just kind of common sense. The class project, when you actually put all of those things into practice, makes it very clear that some of those things are maybe less trivial than they seem at face value. So as you set up your class project groups and as you kind of go into the second week where we start getting really involved in the class project, you need to remember that you should have processes in place within your team to do kind of the following high-level things at an absolute minimum. You should understand how your team is going to react to adding or changing requirements. So you have to have, if not a very formal process for doing this, you have to have some idea of who the gatekeeper for changing requirements is, how you're going to update your documentation, how you're going to implement and test those changes. You also need to understand and work through how you're going to synchronize work. Are you going to require people to check into the Git repository every day, every other day, every week? Are you going to have a branch in your Git repository that should build all the time and should be instantly testable? Are you going to implement continuous integration, continuous deployment? All of that is entirely up to you, and it's worth discussing with your team. You should also have a plan for dealing with breaking changes. So breaking changes occur when somebody makes one change to their code and suddenly no one else's code works anymore. So you should have a process for communicating the fact that now suddenly the application no longer works, and for somebody to take ownership of the fact that it doesn't work and resolve it as quickly as possible. And you should also have some sort of process around minimizing the impact of miscommunication. So you need to be clear who is working on what area of the product. You need to be clear about what tasks are being done by what person so that people aren't doing duplicative work, and also they're not breaking each other by doing that duplicative work. And you also need to minimize the impact of what's called opportunity cost. So if you have 3 or 4 or 5 people in your group and 2 of those people are implementing the exact same feature, that means that there is a feature out there that you missed out on implementing simply because 2 people were doing the exact same task when they could have been doing different tasks. So you need to have an idea around how to manage tasks, how to manage work, how to assign work, and how to make sure that everybody is on the same page with how the product is being built. So that wraps up our discussion of software teams. I hope that you found this first unit kind of informative. Up to this point, everything's a little bit common sense, like I said, but once we get into the group project and we get into kind of the nitty gritty and the more architectural type stuff, I think that you'll find it slightly more interesting. So thanks very much for tuning in, and please let me know via email if you have any problems, questions, concerns, or anything like that. Thanks again.